Assalamualaikum warahmatullahi wabarakatuh. Today, I will be explain about using algebraic equation to solve problems from chapter 2. I made this video to fulfill an assessment for the English Mathematics course by Mrs. Rahmita Norbaiti NPD and Mrs. Eli Kusumawati NPD. Before I start, I will be introduce myself. My name is Nur Aulia. I'm from group 6 with student ID number is 22101183200010. On this occasion, I would like to explain about vocabulary, question on video, and some example. So the first is about vocabulary. Number 1 is odd. In bahasa, odd is ganjil, or we can say bilangan ganjil. So the definition of odd is different than the normal, not divisible by 2 or the one remaining when others are paired. For this simple example of odd, it's like 1, 3, 5, 7, and 9. Number 2 is even. Even in bahasa is genap, or we can say bilangan genap. So the definition of even as whole number that is able to be divided by 2 into 2 equal whole numbers. So for the simple example of the even is like 0, 2, 4, 6, and 8. Number 3, absolute value. In bahasa, absolute value is nilai mutlak. The symbol of absolute value is like this. It's like this. The definition of absolute value or modulus of a real number x is the non-negative value of x without regard to its sign. The absolute value of a number may be thought of as its distance from 0 along real number line. For the example, it's like the absolute value, it's like the absolute value of 5 is 5, and the absolute value of minus 5 is also 5. And another example like minus 3, absolute value of minus 3 is also 3. Next, number 4 is round up. Round up in bahasa is pembulatan ke atas. We can say pembulatan ke atas. So the definition round up is to raise a number to the nearest whole number or 10, 100, or 1000 above it. For the example, 38.7, we can round up to 39. And for the another example, like 31.8, we can round up to 32. Number 5 is round down. The rundown in bahasa, we can say pembulatan ke bawah. The rundown function, so the definition, rundown is a function behaves like the round function. Expect that it always rounds a number down. It can round either to the left or right of the decimal point, unlike start rounding where numbers less than 5 are rounded down. For the simple example, like 3.2, we can round down to 3 because 2 and behind the point, the numbers less than 5. So we can round down to 3. Number 6 is bisector. In bahasa, we can say garis bagi. So, the definition bisector in geometry, bisector is the division of something into two equal or congruent parts, usually by a line, which is then called a bisector. So for the example, line segment bisector, consider a line AB equals 4 cm. A line segment bisector will cut into two equals parts of 2 cm each. Next is centroid. Centroid in bahasa we can say titik pusat. Titik pusat. The definition of centroid is the center point of the object. So for the example, the point when the diagonals of the square intersect each other is the centroid of the square. As well, we know the square has all its sides equal. Hence, it is easy to locate the centroid it. Number 8 is median. My median in bahasa we can say angka tengah. Angka tengah. So median is the middle number found by ordering all data points and picking out the one in the middle. Or if there are two middle numbers, taking the mean of those two numbers. So for the example, the median of 4, 1, and 7 is 4. Why? Because when the numbers are put in order, it's like 1, 4, 7. So the median is number 4 because the number 4 is the middle. Number 9 is finite. Finite in bahasa we can say terbatas. How? Himpunan terbatas. So finite set in mathematics is a set that has a finite number of elements. In a simple word, it is a set that you can finish counting. So for the example, to finish, it's like, what is number under 10 but up 5? So we know the number under 10 but up 5 is like 6, 7, 8, and 9. Or for the example, another like this one. Number 10 is infinite. Infinite in bahasa is tidak terbatas. Tidak terbatas. Infinite. An infinite set is a set whose elements cannot be counted. An infinite set in one that has no less element. So for the example, this set of whole numbers y equals 0, 1, 3, 1, 2, 3, and blah 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 is an infinite set as the number of elements is infinite. The set of real numbers is an example of uncountable infinite set. So next, I will be explain about question on video. So the question in video is create a graph of the linear equation 5x plus 2y equals 20. So the solution is we can do operation 5x. So we can operation 5x plus 2y equals 20. Equals 20. So the 5x we can move the 2 to right, and we can, and this like, so the point, so we can find it, the point of y is equals 10 minus 5 per 2x. So for the operation, we can make the test point like this. This x, y, and y. So for the value of x, we can make the 0, 2, and 4. 0, 2, and 4 we can insert to the point of x. So yeah, so if the point of x is 0, we can find the value of x and y is 0.10. And if we insert the value of x is 2, we can find the value of x and y is 2.5. And if we insert 4 to x, then we can find the value of x here is 4.0. So the next, we can drawing the graphic, and we can insert the value of the point we find it in the graphic, and we can see the graphic will be like this. So next, I will be explain about example. The first is example 1. The question in example 1 is the large of two numbers is equal to 14 more 3 times the smaller number than the small number. Find the smaller number if their difference is 38. So for the solution, step 1, we can step 1, let the small number equals n. And step 2, large number equals 3x small number plus 14 equals 3n plus 14. And for the step 3 is large number, smaller number equals 38. So substitution, the first one and the first two. So the operation like this. 3n plus 14 minus n equals 38. 2n plus 14 equals 38. 2n equals 24 because the 14 removed to right. So the plus will be minus. So 38 will be minus 14. So the total is 24. To find the n, we can divide 24 divide 2, and the value of n is 12. So next, the step 4, large number equals 3n plus 14 equals 3 times 12 plus 14 equals 36 plus 14 equals 50. And the last step, we can check the large number minus smaller number equals 38. We know the large number is 50 and the small number is 12. So 50 minus 12 equals 38. So we get the small number is 38. Example 4. The question of example 4 is Sandy is 4 times as old as Robbie is now. In 10 years, Sandy will be 6 years older than Robbie. How old are they now? So for the solution, we know Robbie, okay, so for the solution, let Robbie x equals h. let Robbie's egg equals egg, and Sandy eggs equals 4 times Robbie eggs. Sandy eggs equals 4x. In 10 years, Sandy will be 6 years older than Robbie. Sandy x equals Robbie's egg plus 6. So we can operation the Sandy x like 4x plus 10 equals for the Robbie egg x plus 10 plus 6. The same variable for x will be a minus x. So we got 3x. And the 10 is constanta. So 3x equals 6. The value of x equals 2. So the Robbie's x equals 2. Sandy's x equals 4 times Robbie x equals 4x equals 4 times 2 the Robbie x, and we can find the egg. Therefore, Robbie's correct egg is 2 and Sandy's correct egg is egg. Example 5. The question is Jessica is 27 years old and Melissa is 21 years old. How many years ago was Jessica twice as old as Melissa? So for the solution, first we know Jessica is 27 years old and Melissa is 21 years old. So Jessica age equals 2 times Melissa age. The asks, how old were Melissa and Jessica a few years ago? Let x equals number of years ago. So we can subtract x number of years ago from Jessica and Melissa age to find out how old they were several years ago. Substituting the past age, we get the equation for the problem. The operation like this: 27 minus x equals 2 times 21 minus x. 27 minus x equals 42 minus 2x. We can remove 2x to left. For the find the value of x. So the operation like 2x minus x equals 42 minus 27. So the value of x equals 15. So we get the x equals 15 years ago. To check, we have to compute the girl's age 15 years ago. Jessica was 27 minus 15 equals 20 years old. And the Melissa was 21 minus 15 equals 6 years old. secretly Jessica, which as old as Melissa. Example 6. The question of example 6 is two cars are traveling on the same highway toward each other from towns that are 115 mi apart. One car is traveling at 60 miles per hour, while the other is traveling at 50 mile per hour. If they start at the same time, how much time do the nurse minutes will have passed at the moment when they pass each other? So the solution, we know the total distance is 150 mi apart. Fast car is traveling at 60 miles per hour, and slow car is traveling at 50 miles per hour. So the asks, when will the two cars pass each other? To the nearest minutes if they start at the same time. So we can drawing a picture can help. The picture like this, the fast card and the slow card. Total distance equals distance traveled by faster car plus distance traveled by slower car. Since the cars start and pass each other at the same time, the time they have both traveled in the same as variable to represent it. Let time travel by both cars equals t. Using the relationship, distance equals rate x times our model becomes 150 equals 60 t plus 50 plus 50 t. 150 equals the 60 plus 50 is a 110. So 110 t equals 150. So we can for define the value of t, we can divide 150 divide 110. So the t is 1.36366 and blah blah blah. So we can round up the t. So the t is 1.37. So the problem asks for the answer to be given the nearest minute. The decimal parts of the hour can be converted to minutes by multiplying 37 times 60 equals 22.20 minutes. So that's all my explain about vocabulary, question on video, and example. Thank you so much for your attention. I hope you enjoy for this video. Assalamualaikum warahmatullahi wabarakatuh.